Hello, my name is Beth Dixon, and this is a video based on Vicki Borlaug's PowerPoint presentation on variance and standard deviation. I wish to thank Mrs. Borlaug for her hard work in making the PowerPoint and for allowing me to use it to create this video. Our goal for this video is to compute the sample variance and the sample standard deviation. And for some quick notation, the sample variance is S squared and S is the sample standard deviation. Variance and standard deviation measure how much the data is spread out. Signed distances are used in their computation. What are signed distances? We have a car traveling down the interstate. The car passes the 100-mile marker and drives forward in a positive direction to the 120-mile marker. If the car travels in a positive direction, the signed distance will be a positive 20 miles. 120 minus 100 gives me a positive 20 miles. If the car travels home in the other direction and passes the 120-mile marker first and then the 100-mile marker, then we have the opposite case. If the car travels in a negative direction, the signed distances will be negative 20, and we represent that with 100 minus 120, or equals a negative 20 miles. Example 1. A set of sample data is given below with the corresponding mean. The units are measured in inches. The distance can be measured using a ruler that's given below. The units on this ruler are also in inches. We will now use the ruler to measure signed distances and then compute the variance and the standard deviation. What sign would we use for the distances of the data values that are to the left of the mean? Remember the car example, or think of a number line. If we're moving to the left on the number line, what direction would that be? For data values to the left of the mean, the signed distances will be negative. What sign would we use for signed distances of data values that are to the right of the mean? Remember the car example, and think of a number line moving to the right. It moves towards which number on the number line? For data values to the right of the mean, the signed distance will be positive. Time to do some measuring. To keep up with our information, we love tables. Mathematicians love tables to organize data. Well, I do anyway. Apparently so does Mrs. Borlaug. So for point A, we have the distance from A to the mean. And we'll illustrate that and measure that. And we have 11. And because it's on the left-hand side, that will be a negative 11 inches. Point B, and measure the distance on the left-hand side, makes it a negative 5 inches. Point C, measure the distance. It's on the right-hand side, so that will be a positive 4 inches. Point D should also give us a positive 4 inches. And lastly, point E, which will give us 8 inches. So here we have our completed measurements. Notice something about this list. If we sum up these signed distances, we will get 0. Negative 11 plus negative 5 gives us negative 16. 4 plus 4 is 8. 8 plus 8 is 16. Negative 16 plus a positive 16 equals 0. That is because the mean represents the balance point of the data. There is the same amount of distance on the left-hand side, a negative 16, as there is on the right-hand side, a positive 16. The mean represents that balance point. We cannot just add this list. We get 0. We need to manipulate these numbers in a way so they do not cancel each other out. One way to do that is to square each number. When you square a number, it will be positive. A positive times a positive is a positive, and a negative times a negative is also a positive. So next, we square each signed distance and find the total. Negative 11 squared gives us 121. Negative 5 squared equals 25. 4 squared gives us 16. 4 squared gives us 16. 8 squared gives us 64. And total those numbers to get 242. Now we're ready to compute the variance and the standard deviation. The variance is a type of average of the distances. So remember that average doesn't necessarily mean the mean. In this case, we can take the total of the square distances and divide by one less than our sample size. The sample data, for sample data, we divide by the sample size minus 1. Again, we're doing this because we have a sample and not a population. That makes our variance 60.5. And again, it's a measure of how far apart our data is. The standard deviation is the square root of the variance. Notice how our notation supports this. We then have the square root of 60.5, which gives us 7.7782. Please check with your teacher about how far to round your answers for both parts of this for variance and standard deviation. Standard deviation is a measure of how far a set of numbers are spread out. So, back to how far apart our points are from the mean, we can say that the sample variance is 60.5 inches squared and the sample standard deviation is 7.7782 inches. Notice the units. Sample variance is squared, sample standard deviation is in single units. Do we deal with this type of data often? No, but data sets in the future may not be measured in inches with a ruler. How will we do those sets of data? Find the mean, variance, and standard deviation for the sample data given below. 4, 10, 19, 19, and 23. I'm going to climb on my soapbox for just a second or two to say that notation is important. Knowing your definitions and notation make learning the material in probability and statistics much easier. X equals the sample data values. X bar equals the sample mean. N equals the sample size. S squared equals the sample variance. And S equals the sample standard deviation. Sigma means to add the values. First, find the mean of the sample. Sample mean equals X bar, the sum of the x's divided by n. We add the numbers and divide by 5 because there are 5 numbers. That will be 75 divided by 5, which is 15. We represent that on the graph. Now we'll find the variance and the standard deviation. How do you find the signed distances without a ruler? subtract the mean from the data value. The mean of 15 is subtracted from 4. 4 minus 15 gives us a negative 11. 10 minus 15 equals a negative 5. 19 minus 15 equals 4. 19 minus 15 gives us 4. And 23 minus 15 gives us 8. Notice the similarity to example 1 with our numbers. So we're actually doing the exact same problem. Notice the values to the left are negative, the sign distances to the right are positive. Time to put our information into a table, just like we did before. And this time we'll be more formal about what we're doing. Notice how we have set up our table. The first column is labeled X and contains our data values. They do not have to be in order, but it can be helpful if they are in ascending order. In the next column, we'll put our sign distances to the mean. Remember how we found those, and we took the data value and subtracted the mean. I won't read through those again, but we'll just transfer those back, and now we filled in our table. Notice in each case what we did was to take x minus x bar being the mean. And that's why the column is labeled that way. The next column is the distance squared. And we square each number from the previous column. And again, I won't read through that. We've just squared those numbers. Notice how the notation is written. It is x minus x bar in parentheses squared. It's the previous column and adding a square to it. Order of operations tells us we need the parentheses. Then we need to find the total of those values. Remember, that's what the capital sigma down here means, to total these values. The total then is 242. Remember our mean. And now we have the mathematical formula for the variance. It looks complicated, but we've already accomplished most of this with our table. Notice the sum of x minus x bar in parentheses squared is what we found by totaling up our distance squared column. So we can plug in 242. N minus 1 is just the number of our data minus 1 for our sample size minus 1, or 4. That gives us 242 over 4, or 60.5. To find the sample standard deviation, we take the square root of the variance. And again, notice how the notation matches this concept because the square root of s squared is s. The square root of 60.5 again is 7.7782. And the sample variance is 60.5 and the sample standard deviation is 7.7782. And I'm concluding this video with 2 activities that you can pause and do on your own. Thank you for watching.